Hey guys, welcome back to my channel Learning Hub. So in this video, I'm going to teach you what is a CNN. Okay, so CNN is also called as a convolutional neural networks. Okay, so in this video, we'll be talking about this convolutional neural networks. Okay, so now without further ado, let's get started. So firstly, let me say what is actually the CNN. CNN is a convolutional neural network. So this is a deep learning model, guys. Deep learning model uses image processing to perform computer vision tasks like image recognition, image classification, or object detection, like that. Okay. So unlike ANN, so this CNN uses convolution layer. Okay, so this is a feature extraction layer. You can see in the image, right? So in this layer, the input is an image, and here from that it will actually get a futures. So futures means, let me say you an example. Like for example, you got a MNIST dataset where you will be having images of numbers. Okay, so the pixels of numbers. So firstly, if it is an image, then the data will be in a pixel format. Pixel format means for each pixel you will be having a particular frequency. Okay, for example, if the input is like this, let's say an example like this. Okay, so you got pixels like this, the input is like this. So if you combine these pixels, right, you will be able to get a number like this. Okay, so this, by seeing this, you can say that this is a 9, right? So to recognize this pattern, we have got a concept called futures. So the relationship between these pixels, like these particular rows and columns, you see these are called as a futures. And to detect these futures, we use convolution neural network, convolution layer. Okay, so see this layer, convolution layer. So unlike ANN is just a fully connected layer. To perform CNN on an input image, right? So we perform mainly three tasks. They are convolution layer, and the second one is pooling, and the third one is fully connected layer. So what this CNN will do is, in the convolution layer, it will actually applies a filter, that is a window, to detect these type of patterns. These are called, they will be having some relationships with each other pixels. Okay, so those are called as spatial relationships. Okay, if you use ANN, right, you cannot perform you cannot actually get the spatial relationship between these, because in ANN, you will be the input data will be flattening. You will convert the input data into 1D. Okay, if you convert the input data into 1D, what will happen is, see, the spatial relationship will be lost. See here in the first layer, this is having a relationship with only this particular box. Like if like this 6 come means, for a 9 it has to form a full circle, right? So that's why this is a spatial relationship with the other pixels also. So if you convert this into a 1D layer, the first row will be like this, and the second row will be lost its spatial relationship between these pixels, because this particular pixel is having a spatial relationship between with this above particular pixel. And if you convert this into 1D, this will be coming first, and this will be coming far away from this. So that's why there will be spatial relationship will be lost. So ANN is not good for image processing tasks. Okay, so that's why we don't use ANN. ANN is just a fully connected layer. That's it. So this is a fully connected layer. ANN uses only this layer. Unlike ANN, what this CNN will do is, CNN will capture the futures. from this convolution layer. Okay, so it will capture the features from image and it will recognize them. So by using filters, this is also called as a kernel. Okay, so we will use this window actually to perform to go through whole data, whole input in this format. Whole input in this format, the window will be moving horizontally and vertically, and it will actually recognize the patterns. So that's how you can detect what will come next. So these many convolution layers, you see. So detecting these, and the next in the next layer you will merge them. So you will get this and this, and in the next layer you will actually perform this. You will merge this and this is how you can actually perform CNN. Okay, so the main concept behind CNN, so that is kernel. Okay, spatial relationships. So now we will know about why we won't use ANN. Okay, why we only use CNN for image processing tasks. Okay, see guys, now let's talk about CNN versus ANN. Okay, so why we will use only CNN for image processing task? Why not ANN? See guys, there are three main reasons for using CNN instead of ANN. See, the first reason is spatial relationships. See, the thing is, before I have said now, like so ANN is just a fully connected layer, and if you are going to uh, convert an image, like if you are going to take an image and input that into a ANN layer, right? So what ANN will do is the first process that will do is flattening the layer. So by flattening the layer, actually, I said no, like for example, if there is a pixel format like this. An image like this, and if you convert this into a 1D array, right, so you will lose the spatial relationships, because the first see here, this first future is having a relationship with this second row, second one. Okay, and this, if we convert this into a 1D array, so first row will come first and the second row will come the second. You see, first row, this is going to be lost spatial relationship with the neighbors, because for this, when it is in 2D format, for this pixel, the down pixel is also having a relationship between those two. So that's why when you convert directly, but in CNN you will use convolution, or else convolution layer, or else future maps. Okay, you can see the image, right? So in these future maps only you will be able to recognize the spatial relationships. But in ANN you are directly not recognizing any spatial relationship, and you are directly doing flattening the layer into 1D array. So then you will be lost these spatial relationships between the pixels, so that your model cannot actually recognize the particular patterns between, or else particular relationship between the pixels. Okay, so the second reason is complexity, guys. See, let's think you got an image. Okay, you got an image, and this is 40 by 40 pixel format. Okay, so this image is a 40 by 40, so this is very small image. Okay, so now what you are doing is, if you perform ANN on this, right, so 40 by 40, your first the thing is, you are going to convert this into a 1D array. So if you convert this into a 1D array, you will get 1600 pixels. Okay, so the first thing you will do is converting this 2D image into a 1D array. Okay, so you will get 1600 pixels, and after that, so if you perform ANN, this will happen. So 1600 pixels. Okay, now after this, you will be having a fully connected layer in ANN. Okay, So what this will have is the first layer, it will have, for example, 100 units. Okay, so like this, you are having 100 units. So each one you will attach to 100 units. Each pixel will go to 100 units. The input layer is made up of 100 neurons. Okay. So this 100 neurons, if you multiply this, then total you will be having like 1600 into 100. Then what this becomes is you need to perform 1,60,000 iterations you need to perform. Okay, that too in the first layer itself. Only 100 units. You need to perform 1 lakh 60,000 iterations to actually recognize the pattern. And this is only a very small image. You If you use only a very small image, you are getting this much complexity. Okay, and if you got an image size of thousand thousand by thousand means, it is going to take so much. It is going to take so much of iterations. Okay, so many iterations are going to happen, and this increases the complexity automatically. But instead, what CNN will do is it will try to like I said, there will be a convolution layer, and in this layer, you will apply a filter and you will reduce the data. Only the important features are going to be detected by this CNN. Okay, so in the convolution layer, you will be detecting only the important features. You will not detect the unnecessary features. So that's why CNN is less complex when compared to ANN. Okay, and the third thing is overfitting, guys. Just imagine you are actually uh, performing this much iterations, and you need to grab every minute relationship. Okay, you need to recognize every minute pattern that is there in this image. Okay, so that is there in this image. Okay, so for that, what you will do, the problem is going to be arise at this time is overfitting. Okay, so to recognize that much minute details, you will actually perform overfitting. You cannot perform like this. So at this time, on the training data set, you will be able to get good results. But when you test the when you test the model with the test data set, you will not be getting that much accuracy because the data will be overfitted. Okay, so if you need to know very uh, minute pattern, you will be training very huge data like this much iterations. It will take the overfitting concept. Okay, so that's why we don't use this ANN. Okay, we will use a CNN instead to perform image recognition or else computer vision tasks. So that's it for this video, guys. In my next video, I'm going to say like the CNN architecture. Okay, so that's it for this video. And if you like this video and my explanation, then please do like this video. And if you're not subscribed to my channel yet, then please do subscribe to my channel, guys. I'll be seeing you in the next video. Okay, bye bye.
Thank you for watching, and I'll see you next video. Happy coding.